have here Marlene Mangani. She is Senior DevRel at Microsoft. She's a friend of mine and also a wonderful voice at the AI ecosystem. And today she'll be speaking to us about a practical guide to agentic coding. So please, a warm welcome to Marlene.
Hi, everyone. Hopefully you can hear me. But yeah, Lace already introduced me. My name is Marlene. I work at Microsoft, and at GitHub, I work on a team called Core AI. So the goal, my talk today is going to be a practical guide to agentic coding. And the goal of the talk is going to be to give us some mental models so that we can understand different ways to optimize our coding agents when we're working with them. Just a note, all of the slides I'm going to show are at the link that is there on all the slides. So, a quick agenda of what we're going to be covering. We're going to start with the evolution of AI and coding. We're going to look at what coding agents are and something called an agentic loop. And then for most of this talk, I'm going to hopefully speed run through some demos of like actual things we can do with coding agents, and then we'll wrap up with some best practices. A good question to start with is, what exactly is agentic coding? So I think some good context for us is that a couple of years ago, when we first started to see AI show up in our code, it was through code completion. So you'd be writing in your IDE, and then maybe you're typing out a function, and your LLM would look at the last 2 or 3 lines of code and then make some suggestions, and you could accept or reject those suggestions based off of whether you liked it. And it's kind of similar to how we have autocomplete on our phone. Then after that, I think about 2 years ago, the labs like Anthropic and OpenAI started to work on LLMs that were specifically designed with coding in mind. And so I actually remember during that time seeing that ChatGPT was getting better with code, and I would go to it and ask it questions or to generate a script. Then I would run the script in my IDE, and then maybe if there was an error, I'd copy the error and put it in ChatGPT. And it was kind of this process of going back and forth, copying and pasting. Does anyone remember that error? It was a bit tough. But the cool thing with that error was that it showed us that LLMs can actually generate good code, and they can work with us with our code. And now I want to say about a year ago, so it hasn't been very long, we really started to see some agentic coding workflows. So for example, at Microsoft, we created something in VS Code with GitHub Copilot called agent mode. And then when a user starts using agent mode or turns it on, Copilot then turns into this sort of autonomous AI agent, and it can do work on your behalf. So the agent is able to run and execute commands in the terminal. It's able to carry out multi-step commands for very long-running processes, and it can also debug its own code. And I think the key thing that changed there was that we gave our agent access to our full workflow. So we're still using the same LLMs that are good at code, but the difference is that we're giving our agent access to the right context and the right tools so that your agent can make decisions and then also take action on those decisions because it has access to the tools in your workspace. Right now, there are a number of different coding agents available on the market today. And I would say we're a bit at an inflection point in terms of the coding agent. So there's a bit of a fight in terms of which coding agent is going to come up on top. I'm a big Copilot fan. Of course, I work for Microsoft, but other people like other coding agents. And the good thing for us as developers is that it means regardless of where you want to work, whether that's in your IDE, you could use Copilot in VS Code. If you're working in the CLI, I know some people, very few people use Claude Code. I'm joking. A lot of people use Claude Code. And then if you're working in the web, you can use things like Codex or Jules. And then you can also build your own custom agents. Pydantic AI is a good example of an SDK that you can use to build a custom agent. And all of these agents that are built, it's sort of like we have something called a harness. So this is the word that's becoming more popular these days, is you build out this harness in code that wraps around the model and it gives the model access to tools and different contexts. So you can use things like Pydantic AI to be able to actually build out the harness. One thing I will say is that even though we have this variety of coding agents, all of them typically work very similarly under the hood. And I think a good way for us to understand how we can get the most from these agents is to understand how they work. So where we can start is by answering the question, what is an AI agent? So this question has been debated in the past, but now I would say a widely accepted definition is that an AI agent is an LLM that runs tools in a loop to achieve a goal. So this is pretty widely accepted. And I would say specifically for coding agents, this agentic loop that you can see on the screen is usually what's associated with coding agents. I actually got this image or the diagram there from a blog post by Anthropic where they were writing about how Claude Code works under the hood. So you have these steps here, and for the rest of this talk, we're actually going to walk through the 3 steps: gathering context, taking action, and verifying results. And we're going to look at how we can optimize our workflows at each step of these points to be able to get the best results from our coding agent. So we are going to start with number 1, which is gathering context. So when you go to your coding agent, wherever that is, you're going to send through a prompt and you're going to ask it to complete a task. And the first thing your coding agent is going to do is it's going to try to gather context, the context it needs to complete that task. And I would say as a developer, one of the main things you want to do is to make sure that your agent, number 1, has access to the right context, to the right files that it will enable it to complete its task, and that it's able to also manage that context in a good way. So we'll look at 2 examples of this. The first thing we can talk about is I'm in VS Code right now, and this is the chat with Copilot. So one way to actually give your agent context is just to attach it to the chat. So if I click on that plus button, you can see I have different options. I could attach a GitHub issue, a pull request, or I could attach a file. So here, if I click on GitHub issues, it's going to automatically detect the issues that are available on this repo. So if I choose this add README one, and if I say, tell me about this issue, then the agent should be able to read through that context, directly pull in information from the issue, and then hopefully in an ideal world, it'll actually get started working on that. You'll use the agent to work on the issue with you. Another thing to note is that we have instruction files. So if you are using GitHub Copilot, these are called Copilot instructions.md. If you're using Cursor, they're Cursor rules. If you're using Claude, MD. And one that's popular right now is agents.md. And if I go ahead and in my chat, I just say hello to the agent is going to respond and say, hi, I'm Marlene's AI assistant for her PyAI talk. How can I help? The reason that it knows to respond in this way is that I have defined a Copilot instruction file, and it says the instructions in terms of how the agent should act. So if I want to control my coding agent and tell it how to behave, it's going to be from these instructions files. And this is sort of at the repository level. Another thing that we need to think about is about context rot or context bloat. And this happens in terms of how much context you're sending to your agent or to your LLM. So there was a study done by the team at Chroma that found that once your agents hit a certain amount of context, or once an LLM has a certain amount of context in its context window, the performance is going to degrade. So you want to be able to manage the context that you are giving your model. If you're using a pre-built harness, for example, here in Copilot, we actually monitor how many tokens are in the code in the token window, and then we'll compact immediately, like if it reaches a certain threshold. But if you're building your own agent. So in this example here, I'm using Pydantic AI, and I've created this function here called compact history. And what will happen is that I've created an agent for Pydantic, and every time this agent runs, it's going to call this compact history function. And what's in the function, what's in the code here, is that the agent is going to take in our messages. It's going to count the total number of tokens that are currently in the context window. And then if the tokens are above 500 tokens, for example, in this case, then it's going to see that a limit has been reached, and it's going to retain only the last two messages. So it'll compact down. Obviously, there's other ways of controlling compaction. You could include a small model or a cheaper model that will automatically summarize for you. And so I will give an example, and I will try to run this code to show you what it looks like. So right at the bottom of my file, I have these messages here where I'm saying, tell me a fun fact about black holes. Actually, I'm just going to run the script, and then we'll read it while it runs. So I ran this earlier. Where is the command? Here. I don't want to have to type it again. Here we go. Okay. So when we run the code, it's going to call the agent and first ask it to tell me a fun fact about black holes. And then after that, it's going to add whatever response is there to the history. And then after that, it's going to add ask it to expand on this topic. And once it does, it's going to also add that to the history, and then we'll follow up with the next question. But what we can see here is that after it ran and gave a response to the second question, we hit our token limit. So there were 700 tokens in the context window. And then because of that, it will only retain the last two messages. So this is one way, for example, that we can think about context engineering in terms of if you're creating your own agents with Python, you want to make sure that you're thinking carefully about this context. Another thing that we want to be able to do with our coding agents is to allow them to take action. There's a number of different ways people do this, but I would say the primary way I use or give my agent tools is through MCP. And MCP is Model Context Protocol. It is an open protocol that standardizes how we give context to LLMs. And my personal opinion is the main way I have seen MCP being used is to give tools or to give access to tools that are from an external third party to your agents. So here, for example, if you're in a VS Code and you want to access an MCP server, you can just type in @MCP, and then you'll get this list of vetted MCP servers. And so if you install them, they'll be available as tools. And actually, if we click on the chat, we see that we have our coding agents. Most typical coding agents today have built-in tools, but we also want to give them access to these external tools. So for example, I have Excalidraw installed here. And if I want to, I could say, can you use Excalidraw to generate an image that explains MCP? And then when I do that, it's going to look at the tools that it has available to it. We've given our agent access to the MCP tool. And we'll see that the first thing that it does is it ran the README tool. And that tool is going to access context from the Excalidraw MCP server. And so we can see that we've imported all of this context about how to use, the agent can use Excalidraw, different formats or commands that it can run to actually get things working with Excalidraw. And then it should hopefully also be able to use a tool from Excalidraw to generate the diagram. And there we have it in our terminal. We can see this very pretty diagram about Excalidraw here, which is super nice. And this is how I would say, this is one way you can use MCP, and that's directly in a pre-built coding agent. But you can also use MCP directly in your code. So I also have a second file with Pydantic that also connects to an MCP server. So if you want to use MCP directly in your own agent that you want to build for yourself, you can use Pydantic AI. You're going to connect either to a remote MCP server or you can run a local version, and then you pass in the server as a tool. And so if we run this command here, and I'm just going to run Python. What did I name it? Pydantic MCP agent.py. And then if I run this, my question is, I was like, what issues are open in my ACM Tech Talk repo? So I gave another talk and I want the agent to get access. I gave it access to the GitHub MCP server. So there's a number of different MCP servers that are available online. You can just look for them. And that should give my own agent access to an MCP server. It can look for information using that server and will hopefully give us a response. It's a bit slow. Maybe it's the internet. Oh, there we go. And then it shows me exactly which issues are available on this GitHub repository. So this is a great way to bring both in a pre-built coding agent and also with your own code, bring in context and bring in tools. Okay. I'm almost done with time. Okay. Okay. So that's pretty much, I will skip through. One thing that I also wanted to show was that it's probably good to verify that your agent has generated good code. Playwright is a good way to do that in a browser. I'll be talking about Playwright at AI Engineer. So if you come to my talk on Friday, I'll demonstrate how you can give an agent access to a browser so it can test out your app or the code dynamically. I also mentioned that there's been a couple of studies that say if you're going to be writing things like your agents.md or your instruction files and skills, which give your agent access to tools, a human should be the one that writes those files because it improves the performance of the agent. And sometimes if the agent writes it itself, then the performance is actually degraded. So probably a good place for humans to get involved. So this is probably where I'm going to stop in case we need time for questions, but this is pretty much what we covered today. All right. Thanks, everyone.
Thank you. Do you want to take questions? Do you want to take one question? So we have time for one question. Anybody?
Hello, hi.
Yes.
Can you expand on the last thing that you said about agents.md being written by humans and not agents? Yeah.
Okay. Yes, I can expand on that. So there was a study released, I want to say earlier this year or towards the end of last year, that showed they actually tracked to see what was the improvement. So when we create something like an agents.md, we're creating sort of a specialized agent. So we've given it all this context that you need to behave in this specific way. And what they found was that if we had this task that we wanted the agent to do, and we had the LLM itself generate an agents.md or generate a skill.md file, then the skill actually on average, the performance of the agent would be less good. So if a human created, on the other hand, if a human created that skill, so was detailed in terms of do this, take this step, do that step, and a human was the one that curated it, maybe with the help of an LLM, the performance would go up 16%. Whereas sometimes if an agent created it, the performance would go down 20%. And actually in one example, it actually made it so that the agent spent more time thinking and using more tokens, and so it was more expensive. So those links on the screen, if you take a picture, that will lead you to the study that I found. Does that help? Okay, cool.
Wonderful. Thank you so much. Come on. Thank you.